Network and Nature Conservancy series, second in the series of our 2014 sorry, I need to get my notes up here. Our 2014 series. We're working with, this is Jeannie at the Nature Conservancy. I'm the communications lead here for the LANDFIRE team. And we formed a partnership with the Northwest Fire Science Network, along with the Joint Fire Science Program, to run a series of webinars across the U.S. in 2014, looking at the various network geographies, bringing in background material, case studies, and an opportunity to do a little bit of customizing with you using some of the LANDFIRE tools. I'll jump in at the very end of this after Ryan's completed our program and give you my communication information, how you can reach me by email and how you can reach LANDFIRE by email should you want to do any follow-up with us. So we're going to move on and talk to you. Second slide here, if you'll forward it. Could we have this? Oh, whoops, I'm looking at mine. Sorry about that. LANDFIRE, here it is, the Northwest Fire Science Network. We have finished LANDFIRE 101, which is our introduction. The recording is posted. You can hear the whole thing and invite your friends to take a look at it. It might give you some pertinent background that you don't have now. Today, Ryan is going to talk about using LANDFIRE products, assessing restoration needs in the Pacific Northwest. And on April 2nd, Corey Blankenship is going to do that customization piece. She's going to look at methodology to modify LANDFIRE data. And this is specific to this particular region. She's going to pick out one or two tools, and she can show you how that works. So I'd like to turn this over to Ryan now, give us an introduction, and continue with the show, if you would.
Great. Well, Jeannie, thanks so much for that introduction, and welcome everybody. Thanks for joining us, whether it's a morning or lunchtime or wherever you might be across the country. As Jeannie said, I'm an ecologist working with the Nature Conservancy in Washington and Idaho, and I'm going to be talking this morning about how we've been using, we being the Nature Conservancy, our Forest Service partners, and some of our state partners have been using LANDFIRE data and products to look at forest restoration needs across the Pacific Northwest. The outline for my talk this morning is really pretty simple. I'll first set the context for the Nature Conservancy's conservation work within large western forest landscapes, and then we'll dive into how we've put the LANDFIRE data and concepts to work. I wanted to mention that if you guys have questions as we're going through the talk, feel free to put those into the chat box, and I'll try to address those at some of the breaks between sections. And then we'll also have a broader discussion session at the end of the slides. Okay, jumping right in. As many, if not most of you on the webinar, I'm sure are probably well aware, historically fire was a very important part of many forests across North America, particularly within the West and the Southeast. Unfortunately, there's a very common storyline for these historically fire-dependent forests across the West. Our history of 20th century wildfire suppression, harvesting, and grazing has left these forests susceptible to uncharacteristic disturbances such as the megafires that we see in the news and catastrophic insect and disease outbreaks. This is a concern to many of us because these disturbances threaten not only the tremendous biological diversity supported by these forests, but the benefits: clean air, water, fiber production, fish and wildlife recreation that millions of people depend upon. So while the challenges at these forests seem daunting, we have hope. One of the Conservancy's major strategies is to achieve conservation through active ecological restoration, using tools such as prescribed fire, mechanical thinning, and harvests. And really, as I'm sure as many of you are aware, ecological restoration has really become the dominant paradigm for the management of federal forests across the West. This is also leading to an exciting synergy between conservation and local communities that are economically dependent upon the forest industry. large part, TNC or the Conservancy, we are seeking to achieve our conservation and restoration goals on public lands by working through collaborative groups. Collaborative groups where that bring together loggers and sportsmen, ATV riders, snowmobilers, environmentalists, local governments, tribes, and many others to try and help solve land management conflicts. And an important role that the Conservancy has taken in these collaborative groups is to help these very diverse groups of stakeholders to develop what we call a shared vision for forest management. And developing these shared visions, one of the most daunting questions that both the Conservancy and the collaboratives at large face is determining just where, how much, and what kinds of forest management we want and that we need for our collective outcomes. And we have to address these questions at the scale of millions of acres. And this question of where, how much, what kinds of forest management, it's a critical question to answer. How do we know if the pace and scale of our restoration efforts are making a difference out on these landscapes? Okay, so these were some really big questions for us and the collaboratives to answer, and luckily for us, or for me at least, it was LANDFIRE to the rescue. Seriously though, 3 years ago when I started working with collaborative groups in Idaho and Washington, it quickly became evident that LANDFIRE is both an invaluable source for um, continuous and consistent data on both current and natural reference conditions, and also the LANDFIRE staff, Randy, Corey, uh, Jim, Jeannie are just incredibly helpful people and great to work with. So in these collaborative landscapes, we've broken this up into two primary tasks. The first of which is to compare how forest structure and composition today relates to natural reference conditions. And then to go the next step and to look at what actions could move today's landscapes back towards these natural reference conditions. And I always want to be very clear when talking about our use of natural reference conditions. We're not implying that that is necessarily the desired condition for federal or private forests, but it provides us in a very important and useful tool for setting context. How do we make an apples to apples comparison across large landscapes? So as I've been implying, our work to develop an approach for assessing forest restoration needs has initially focused on the interior forests of eastern Washington in the blue and the Clearwater Basin of northern Idaho in the red. However, at the very same time, that I was working in those eastern Washington and Clearwater Basin, the Nature Conservancy in Oregon, the U.S. Forest Service, Pacific Northwest Regional Ecology Program is doing very similar work. So now we're working in a multi-state partnerships across Oregon, Washington, and Idaho, working with the U.S. Forest Service and LANDFIRE to look at restoration needs analysis across all three states. And I'll be showing some of our initial draft outcomes from the Washington and Oregon analyses today. So as Randy described in the LANDFIRE 101 presentation last month, at the heart of LANDFIRE is a classification of landscapes into different biophysical settings. And that each biophysical setting has a collection of, and that these are a collection of models that describe the historic relationships between these settings and ecological processes like growth and succession, fire, insects, disease, and other dynamics. So in Randy's presentation last month, he had a really great story about how when he was a young ecologist right out of grad school and he was in his first position, he had just assumed that you could go out and there was, basic ecological data, that somebody had already done the work to describe how ecosystems across the US would work under a natural disturbance regime, and that was just on the shelf and he could use it. But at that time there wasn't. So I mean, honestly, lucky for me, when I started my work with these collaboratives, all the information was compiled and accessible through the LANDFIRE biophysical setting layers and models. So I'm definitely grateful for the work that LANDFIRE had done, giving me a leg up on when Randy had started. So Randy also talked about, discussed how both natural or historic reference conditions and current conditions today for each biophysical setting are described in terms of successional classes. So this hypothetical figure that I have on the screen would represent one biophysical setting within one landscape. So then each of these 5 successional classes is defined in terms of species, canopy height, and canopy cover. Then the vast majority of our analyses are based on a comparison of the relative abundance of these 5 successional classes present day compared to the natural reference conditions. So when we make these comparisons between natural reference and current conditions for many biophysical settings across many landscapes and roll this up, it allows us to evaluate ecological or vegetation departure. This is formerly known as fire regime condition class. At the most basic level, departure is a measure of how different today's forests are from natural reference conditions. 0% departure means that today's forests are exactly in line with the natural reference condition. 100% mean the forests today are completely different. So looking at our departure analysis across the interior forests of eastern Washington, see that across these 12.4 million acres, 73% have a structure and composition that is moderately to severely departed from the reference condition. Also, departure levels are highly variable across our region. For us in Washington State, the highest levels of departure are in and around the forests of the Methow Valley in the north central Cascades. So just to be clear, the LANDFIRE data that we put into these departure analyses included the biophysical setting, maps and models, the layers of existing vegetation type, existing vegetation canopy cover, and existing vegetation height. These are all available from the LANDFIRE program, and we modified some of the models and some of the data layers with local expert input. So departure has been an incredibly interesting way to look at our landscapes, and the collaborative groups that I work with have really adopted the departure maps and summaries. But looking at departure alone leaves us with the question of why are these forests out of whack, so to speak? Departure in our forests could be the result of widespread clear cutting or because of wildfire suppression. And it's really important to distinguish why are the forests departed, because the need for restoration in these two instances is clearly very different. So, comparing the relative abundance of successional classes today versus the reference conditions can give us some indication of what's wrong. For instance, again, looking at eastern Washington, we see that in those forests that were historically characterized by low severity fire regimes, today we are dramatically short of late development open canopy forests, and we're way overabundant in closed canopy forests. This is exactly what we would expect from a history of wildfire suppression. However, surprisingly for us, in the historically mixed severity fire regime forests, that same pattern doesn't hold true. And just simply presenting graphs of successional class distributions still doesn't really tell us where, how much, where, and what types of actions are needed to reduce or eliminate departure. This has led us to focus on the next phase of our restoration needs analysis. So just over a year ago, we launched a collaboration between the Nature Conservancy in Oregon and Washington and the U.S. Forest Service Pacific Northwest Regional Ecology Program. So using the best available data, we are working to explicitly estimate the numbers of acres in need of restoration across all forest lands on all ownerships within the Pacific Northwest region. And While this analysis is, remains based upon LANDFIRE's conceptual framework and uses the biophysical setting reference models, we've used data sets specific to Oregon and Washington in order to classify and map the forested systems and to measure current forest structure and composition. So, as I discussed with departure, the idea here that our forests are out of whack because we have acres in the quote unquote wrong successional classes based on our modeled natural range of variability reference conditions. So again, this hypothetical figure on the screen would represent one biophysical setting within a particular watershed. And what we see when we're looking at this is that some of the successional classes are in deficit compared to reference. Those would be represented by the orange boxes, while others are overabundant, the red boxes. Restoration of forest structure would mean that we are rebalancing these successional classes today, moving the excesses into the deficits. The approach that we've taken to do this work is that at a coarse scale, we can define what action would move acres from any one successional class to any other if that particular transition is needed to rebalance the successional classes and restore today's forest structure to the reference condition. So to produce higher level summaries of restoration need, we roll up all of these specific transitions into three broad categories. The first is what we've termed mechanical or fire-only restoration need, where restoration requires a reduction in canopy cover and our tree density. And this is, moving stands to an earlier development successional class and or to a open canopy successional class. And so I fully acknowledge that on the ground, the ecological impacts of mechanical treatments and fire are very different. At the coarse 30,000 foot level that we're working with these analyses, we're not distinguishing between mechanical thinnings and fire, and consider that the transitions we are looking at or with the land or with these models could be accomplished through either fire or mechanical treatments. Uh, so in contrast, we also look at successional restoration, or those instances where it is growth and successional processes that are needed, allowing stands to grow into later development successional classes. And finally, as is very common in Western forests, we have a third category which we've termed mechanical fire then succession to represent those instances where restoration requires both a thinning to reduce density or canopy cover today, along with time for those stands to grow into older and larger structures. Okay. So diving into some of this draft output, a snapshot look of restoration needs across Washington and Oregon. We see that across the nearly 29 million acres of forests that we have evaluated so far, we found that 34% are presently in need of either mechanical or fire restoration. Um, Overall mechanical fire restoration needs are highest within Southwest Oregon and Northeast Washington. And within both of these regions, the needs are dominated by the mechanical fire, then succession needs, showing that it's, today we have too many forests of dense small trees, and we're lacking in large, old, open forest structures. However, another way to look at these region-wide restoration needs that is within the Oregon Blue Mountains and within the Oregon East Cascades, where the majority of mechanical fire restoration needs are found on U.S. Forest Service lands. Across the other regions, the U.S. Forest Service lands do not constitute a majority of these restoration needs. Similarly, successional restoration needs either alone or preceded by mechanical and fire, are also highest within Southwest Oregon and Northeast Washington. However, so even looking at the Washington East Cascades, which had the lowest overall relative need of restoration need at the regional scale, we still find substantial levels of mechanical fire restoration needs. Within the Washington East Cascades, we found that nearly 280,000 acres, or 21% of all forest lands on the non-wilderness, non-roadless portions of the national forest are currently in need of um, mechanical or fire restoration need. Breaking these summaries down by forest types, we also find huge discrepancies. Again, within these Washington East Cascades, the mechanical fire restoration needs are concentrated in both the pure ponderosa pine forests, which are relatively uncommon in the Washington East Cascades, yet over 50% of those forests are in need of mechanical fire restoration, and in the much more common dry mixed conifer forests, where it's over 500,000 acres, and 42% of all dry mixed conifer forests are presently in need of mechanical fire restoration. As we move up in elevation to the cooler, wetter forest types, these mechanical fire restoration needs drop off substantially. And so finally, then we're able to use these analyses to take a first look at comparing restoration needs amongst watersheds, but also being fully cognizant of the dangers that come with zooming in too closely to this data. So on the map here showing the Washington East Cascades, this dark outline is the Taposh Forest Collaborative, one of the collaborative groups that I work with. This was presented to the Taposh Collaborative 2 weeks ago, and they're helping to form strategies using these analyses to look at how Forest Service and state agencies can work together to focus on the specific landscapes within the East Cascades region to address these restoration needs. So many of the next steps for this work are how do we incorporate climate change? I'm sure many of you would recognize that that was conspicuously absent in our work thus far, and we're looking at approaches to not just work with historic or natural reference conditions, but to look at how we might use climate change projections to look at future climate reference conditions. The data that we've been using to map current conditions across our landscapes is about, represents frankly 10, 12 years old. So we're working with partners at Oregon State and the Forest Service to update our mapping of current conditions, which will allow us to look at how restoration needs more accurately reflect today's landscape and how they've changed over the past decade. And they're also very interested in linking these restoration needs to social and economic considerations. How do we compare economic and ecological outcomes, and how do we determine how much will this needed restoration cost? So lots of exciting directions for us left to go with these analyses. So before I wrap up, there have been a whole ton of people who have been, centrally involved with these analyses. Chris Sanger and the folks at the Nature Conservancy in Oregon, again, the LANDFIRE team, Corey, Randy, Jim, Jeannie, the U.S. Forest Service Region 6 Ecology Program, Tom DeMeo, Angela Ski, Mike Simpson, Jane Curtis, Kim Mellon McLean, colleagues at the Washington Nature Conservancy, Leanne and Darren, colleagues in Idaho, Nathan and Bob. This really has been a team effort to tackle these restoration needs analysis. And so with that, emails on the screen. Please feel free to jump into questions here on the webinar, but also follow up with me on email if you'd like to dive into it. Links here to a couple of the reports that we have previously put out from these analyses. And so with that, I would be happy to talk about any and or all of this work. So thanks for listening in, everybody.
Hi. Hi, this is Jeannie stepping in here. Thanks, Ryan. We've opened up the chat line. If you've got anything that you'd like to ask us, go right ahead and type it in there. I've posted my contact information should you want anything more directly from Landfire. I'm jpatton at tnc.org, as you can see, and our Landfire at the Conservancy main email is landfire at tnc.org. We're on our Conservation Gateway website. We have a Twitter feed, all kinds of ways that we can communicate with you, and you can come back to us. So please contact us, contact Ryan. We're here to help.
Yeah, and I might mention, I know this was nationwide. We had some folks on the East Coast. We've these approaches are not, not only applicable to Western forests. I know Nature Conservancy colleagues currently working in Central Appalachians have been taking some of this framework and have been um, applying that with their work on national forests in the Appalachians. So it's been exciting to see how we can expand from these dry Western forests to a broader suite. So it looks like we have the first question from Kavi. Is there a difference between departure and serial state? Yes, departure is a synthetic metric that allows us to look at how at the difference at the differences across all serial states. So it allows us to break down those, 5 different serial states. How do you bin up those differences into one specific number? Um, so it allows us to map out those differences. Does that make sense, or please let me know if you need more detail there.
I'll take a second to let you know while Kavi's typing again that adding to what Ryan said, talking to our East Coasters and elsewhere, our webinar series is set up so that the same structure applies to each of the networks we're going to talk with and hear from. The first one is always going to be our Landfire 101 to give people the context and the background. The second one will always, as far as we can tell, be assessing needs, where we'll present a case study, publication, application in that particular geographic region. And then the third one will always be customizing data, where we'll take one of our gajillion tools and look at that particular geographic region and show how it works. I'll remind you that the Landfire team is available to help anyone customize their own data. We work with maps, models. Our team is on call if you need any specific assistance. That's what we do. So please write me a note at landfire at tnc.org if you want to follow up with your particular region. The series that we have going right now is the Northern Rockies and Southern Rockies Fire Science Networks. We've already done Landfire 101. We're about to post it. On March 20th, we're going to look at the Grand Teton National Park and Bridger Teton National Forest. And then on April 23rd, Don Helmbrecht is going to be looking at particularly fuels examples on using Landfire data in the Rockies region. So if you have friends you'd like to send to us, please do. And we'll be announcing more series as the year unfolds.
Well, as I said before, feel free to type any questions that you have, and/or don't hesitate to shoot me an email down the road. If you have any questions about this work, or thoughts on, if you're interested in applying these ideas or concepts, or want to talk about how this might be applicable on the landscapes that you are working with, yeah, I would love to talk to you.
Okay, I think that closes our webinar for today. Thanks again, Ryan. And we'll encourage you to contact him. You have his information there. Contact us at Landfire if we can help you out. Thanks for taking your lunchtime, your brunch time, your morning break with us. That's it. Bye-bye.
Thanks, everyone.